Welcome to this tutorial, where we'll be redesigning this engine cage for improved topology and compatibility with game engine shaders and physics. We'll be focusing on a practical approach to create clean and efficient geometry. The current cage design presents some challenges. It's constructed from intersecting tubes and a central cap. While this model is relatively low poly and largely invisible during gameplay, the topology is suboptimal. As you can see, the various elements intersect, creating a complex web of faces. Maintaining clean topology is crucial for game asset development. Avoidance of overlapping faces and, importantly, intersecting faces is key. Intersecting faces can negatively impact shader performance and physics simulations. Let's look at why this matters. Shaders like ambient occlusion rely on sharp edges to accurately render shadows. Intersecting faces create corners without defined edges, preventing the shader from properly calculating these shadows. Similarly, for realistic damage simulation, a clean topology with defined vertices and edges is essential to provide sufficient data for impact and deformation calculations. Ultimately, a well-designed topology ensures your assets are fully compatible with shaders and game physics, leading to a more polished and performant final product. While modern graphics cards can render this topology, it's best practice to adhere to clean mesh principles, allowing for overlapping vertices and edges but avoiding intersecting faces. Rather than attempting to fix the existing topology, I've decided to completely redesign this component. It's a relatively simple part, so a full redesign will be quicker and more effective. Let's get started. First, select the engine cage and detach it into a new object. Name it appropriately. We'll use the original cage as a reference throughout this process. We'll begin by creating the primary structural elements using cylinders. Isolate the new object to keep our workspace clean. Switch to the front viewport and navigate to the Creation menu. Select Cylinder. We'll use the keyboard entry for precise control. We're primarily concerned with the radius and length. The default units are meters. We want a diameter of 5 mm and a length of 1.25 meter. Set the number of sides to 8, the height to 2 and cap segments to 1. Let's increase the radius to 15 mm. Select the cylinder. Switch to the Move tool. Zero the X-axis value in the keyboard entry. Now, go to the Pivot menu and click on Affect Object Only. Then, click Center to Pivot to position the pivot point at the center of the cylinder. This is crucial for accurate alignment in the next step. With the Move tool, align the cylinder to the original cage along the Y-axis. Next, clone the cylinder as an instance. Rotate the first instance 45° counterclockwise and the second instance 45° clockwise. Apply the Edit Poly modifier to one of the instances. Remember, since we cloned as instances, any changes we make to one will be mirrored on the other. Select the side edges and use the Connects tool to join them. I've intentionally created two loops, allowing us to adjust the gap between them. Set the gap value to 94. Now, let's remove the outer loops and keep the ones closer to the center. Repeat this process. This time, set the gap to 77. We need to create the cap openings. Select the polygons near the intersection on opposing sides and delete them. You'll notice a mirroring issue. The deleted polygons are mirrored, but not in the direction we desire. We could attempt to mirror one of the cylinders, but that won't resolve the problem. To correct this, rotate one of the instances 180° around the local Z-axis. Editing multiple instances can be complex, so let's leverage the benefits of instances while we can. Now, let's clean up. Delete the polygons at the center of the cylinder and remove the cap polygons. On the object level, make one instance unique and then attach it to the other. Use the bridge tool to close the holes on each side. Collapse the nearby vertices, then connect the vertices at the center. Select the edges at the center and apply a chamfer as shown. Clean up any remaining extra vertices. Now let's correct the smoothing groups. Select all polygons and, in the smoothing group section, assign group 2 to them. This will give the mesh a smoother shader appearance. Use the Move tool to align the cage to the desired position. To finalize the design, apply a Turn to Polys modifier and limit the faces to 3. Adjust the bottom side of the cage as needed. Let's explore an alternative scenario, creating flat sides on the cap. Select the cap side polygons and use either the Scale tool or the Make Planner command. Notice how the cylinder deforms as a result of flattening the connected polygons. This behavior persists even when using local coordinates. To maintain the cylindrical surface while flattening the cap sides, we need to detach the cap sides into separate elements before flattening them. Use Snap to Vertices to reposition the flattened elements. Switch to local coordinates in the top viewport and extend the open edges until they intersect with the flat side. Then, switch to the perspective viewport, enable Constrain to Edges, and align the edge vertices to the flat surface. To correct the intersecting edges between the cap and the cylinder, create a loop on the cylinder using Swift Loop. Switch to the Scale tool, set to local coordinates, and scale the selected loop on the y-axis until it's completely flat. Rotate the loop to align it parallel with the cylinder's open edges, then move it towards the intersection. Use Snap to Vertices to refine the position. Select the intersecting polygons before moving the loop, then delete them. Repeat this process for all remaining crossed sections. Remember to weld any overlapping vertices and correct the smoothing groups. The resulting sharp edges on the cap may not be ideal. If we're retaining these ring edges, it's often preferable to smooth the surface to avoid a harsh appearance. And that concludes this tutorial on redesigning the engine cage. By following these steps, you can create clean, efficient topology that's compatible with shaders and game physics.